Atomic mass unit. Atomic mass unit, AMU, a unit used to measure the atomic mass of atoms, molecules, or subatomic particles. Group members: Aidan Gunner and Courtney Kemp.
1.2 Topic clearly identified, briefly introduced. Atomic mass unit. Define AMU. The atomic mass unit is a unit of mass used to express atomic and molecular weights. Introduce significance. Used for comparing atomic mass on a relative scale. One point three Relevant fields. Physics. Isotopic analysis, nuclear reactions, chemistry, stoichiometry, and molar mass. One point four Relevant scientists. Dalton John, contributions. In the early 1800s, he proposed the atomic theory, relevance. Dalton established the foundation for our understanding of atomic mass by being the first to assign relative atomic masses to elements. Dmitri, contributions. The periodic table of elements was developed. Relevance. The idea of consistent atomic weights was validated by using atomic masses to arrange elements. Thomas J.J. measured the charge-to-mass ratio and made the discovery of the electron. Relevance. His research improved the understanding of atomic structure and produced more precise estimates of atomic mass. Aston Francis, contribution. Developed the mass spectrometer. Relevance. Determined accurate isotopic masses, creating the notion of isotopes, and showed that elements can contain atoms of various masses. This was critical to determine the atomic mass unit. Ryland Wynn and Arthur Jeffrey, contributions. Improved mass spectrometry techniques. Relevance. Helped in determining the masses of isotopes with high precision. International Union of Pure and Applied Chemistry. Contribution. Standardized the definition of the atomic mass unit. Relevance. In 1961, IUPAC designated carbon-12 as the reference standard, defining 1 AMU as 1/12 the mass of a carbon-12 atom. Experimental process impact original. The AMU was developed in the 20th century with the idea of comparing atom masses to a standard reference. The initial experimental approach involved determining the mass of hydrogen atoms, which were assigned a value of 1 AMU. Scientists such as John Dalton and J.J. Thomson contributed to our understanding of atomic mass. 2.2 Early chemical reaction used relative mass comparison. Hydrogen assigned a mass of 1 for comparison. Experimental process impact original. 2.3 The motivation for developing AMU was to have standardized universal unit for comparing atomic mass. Prior to the AMU, chemists had trouble discussing atomic weights on a consistent scale. 2.4 The development of AMU enabled chemists to more easily compare the masses of various atoms. It simplified chemical calculations and contributions to more precise molecular formulas.
Experimental process / impact. Modern. 3.1. Modern techniques for determining atomic mass use highly precise instruments such as mass spectrometers. These devices can measure the mass to charge ratio of ions and calculate atomic mass with extreme precision. 3.2. Unlike the original methods, which used relatively crude equipment, modern methods use advanced spectroscopy, laser cooling, and quantum mechanics to achieve much higher precision. Experimental process / impact. Modern. Continued. 3.3. The modern understanding of AMU enables highly accurate isotope measurements, which are critical for a wide range of applications in chemistry, physics, medicine, and environmental science. 3.4. As technology advances, we can expect even more precise measurements, particularly with the use of quantum technologies and improvements in mass spectrometry. Future research may reveal more about the behavior of subatomic particles and how AMU interacts with other fundamental constants of nature. Example question. Motivation / development. 4.1. A good question is to ask is how did the development of the atomic mass unit, AMU, influence the evolution of atomic theory? This is significant because the AMU is essential for understanding atomic masses, a fundamental concept in atomic theory. 4.2. Understanding this question would shed light on how the AMU contributed to the clarification of atomic structure, as well as the advancement of chemical and physical sciences. It also aids in the translation of theory into practice. Example question. Motivation / development. Continued. 4.3. The question was written to determine the relationship between the AMU and atomic theory. It reflects the shift in how we understand atomic structure from early speculation to modern precision. 4.4. Next, a fundamental unit, AMU, to a broader scientific concept, atomic theory, demonstrating the relationship between the measurement and the theory. Here we have an example question, demonstration / solving of how to calculate what is the mass of an oxygen atom in kilograms if its mass is approximately 16 AMU. Conclusion. Scientists' understanding and measurement of atomic and molecular masses have been completely transformed by the atomic mass unit, AMU. The AMU has evolved from John Dalton's early conceptual theories to extremely accurate contemporary methods like mass spectrometry, and it is now an essential part of chemistry, physics, and many other applied sciences. Its advancement made it possible to perform more precise computations, gain a deeper understanding of atomic structure, and improve technological applications in a variety of disciplines, including environmental science and medicine. The AMU's accuracy and usefulness will only increase as technology develops. Sources.